welcome to my YouTube channel Tech Spot. This is me, Harish Goupale. So basically in today's video, we are going to discuss about the concept of binary to gray code converter and the ideal design implementation of binary to gray code converter. If I talk about binary to gray code, so basically it's a type of code converter that can translate a binary code into its equivalent gray code. Basically, it accepts the binary number or binary code and it produces corresponding gray code as an output. It comes into the category of non-weighted binary code, and it is also called as reflective code, unit distance code, and minimum error. And basically, it is used for error reduction or error correction in digital system. There are few steps that we have to follow for the binary to gray code converter. The step 1 is the MSB of the gray code, that is the output, should be same as the MSB of the binary code, and the remaining subsequent bit of the gray code, output gray code, should obtain by performing XOR operation between current binary bit and the previous binary bit. Okay. Now, if I, for example, let's say we have binary code 101010. Okay. If we convert into the gray code, then the output will be 1 1 1 1 1 and 1. Now how it comes? Let's see. As per the instruction, we have to assign MSB of binary same as it is to the MSB of the gray code. So you can see that my MSB, that is B1, that is 1, is assigned as it is to the gray code MSB of the gray code, that is 1. Now the subsequent bit for the gray code, that is G2, G3, G4, G5 is calculated by using XOR between the binary bit, current binary bit, and the previous binary bit. So here you can see the output G2 is the XOR operation between B2 and B1. Okay. Output of G3 is the XOR operation between B3 and B2. Output of G4 is the XOR operation between B4 and B3, that is 0 and 1. So output here you can see 1. Output for G5 is the XOR between B5 and B4, so 0 XOR 1. So output here you can see 1. And the output for this G6 is XOR between B5 and B6. So 1 XOR 0, output is 1. Okay. Now let's see the implementation of 4-bit binary to gray code converter. So here you can see the truth table where we are having 4 bits. As we are having 4-bit binary code, so the combination becomes 16. So you can see the first combination, that is 0. All 4 bits are 0. So if you convert into the gray code, so here MSB is assigned as it is to the MSB of gray code. So here you can see B3 0. So my G3 is also 0. Now remaining G2, G1 and G0 is calculated by using XOR between current binary bit and previous binary bit. So you can see G2 is calculated between XOR between B2 and B0. So 0 XOR 0, output is 0. Now for G1, XOR between B2 and B1. So 0 XOR 0, here you can see the output 0. Similarly for G0, 0 XOR 0, output is 0. Now for the second binary code, that is 1. So here you can see 0 is assigned as it is to the MSB of gray code, 0. Now XOR between B2 and B3, that is 0 XOR 0, is assigned to the output G2, that is 0 only. Now again XOR between B1 and B2, that is 0 0. So output is 0, that is assigned to the output G1. Now XOR between B0 and B1, that is 0 and 1. The output is 1. So the output 1 is assigned to the output D0. Now the third binary code is 0 0 1 0. So 0 as it is assigned to the MSB of gray code, that is 0. Now XOR between B2 and B3, that is 0 XOR 0, is assigned here, output 0. Here you can see 0 XOR 0, output is 0. Now XOR between B2 and B1, that is 0 XOR 1, so the output is 1, that is assigned to the output B1. Okay. Now XOR between B1 and B0, that is 1 and 0, that is assigned to the output G0. So here you can see output G0 is 1. Similarly, we have converted all the binary code into the gray code. Okay. Now let's jump for the RTL design implementation of 4-bit binary into gray code converter. here you can see my screen. I have already written and System Verilog code for the RTL design implementation of binary to gray code converter. So let's go through the code. Here my time scale is 1ns divided by 1ps. My model name is binary to gray. Here I have used one parameter of bit size is equal to 4. And here we are using only two signals, that is one is input and another is output. So our input signal name is binary, which is bit size minus 1 down to 0, means 4 minus 1, that is 3 down to 0, means 4 bit of binary input. Similarly 4 bit of gray output. My output signal name is gray. Now as per the truth table of 4 bit of binary to gray code converter, what we have to do, how to assign MSB of binary as it is to the MSB of gray. So here you can see I have assigned MSB of binary as it is to the MSB of gray. Okay, now third bit of binary XOR with second bit of binary is assigned to the second bit of gray code. Second bit of binary XOR with first bit of binary is assigned to the first bit of gray code, and the first bit of binary XOR with first bit of 0th bit is assigned to the output gray code of 0th bit. Okay, if I execute this code, then it gives me this schematic where you can see MSB is directly assigned a binary. MSB of binary is directly assigned to the MSB of gray, and the subsequent bits are produced or generated by using XOR operation between the current binary bit and the previous binary bit. Okay, now to verify this simple binary to gray code converter, I have written a simple TP code also. Here you can see tick time scale is 1ns divided by 1ps. My module name is TP for binary to gray code converter. Same parameter I have used here, a 4 bit of input binary and 4 bit of output gray. Okay, this is the instantiation, and inside the initial begin I have used here for loop where I have given 10 nanosecond delay for each binary code, and I am as we have 4 bits, so total 16 combinations become, so I have given a limit 16. Okay, now if I click on this run simulation, so I have already run this code. Let's see the output. Here you can see, as I have explained you in the truth table, if my binary code is 0, so gray code is also 0. Okay, if binary code is 1, so gray code is also 1. Okay, because 0 is assigned, this MSB is assigned as it is here. Now XOR between 0 0, here you can see output 0. XOR between this 0 and this 0, output is 0. XOR between 0 and 1, output here you can see 1. Now if I come to this binary code, that is 0 0 and 1 1, so here you can see 0 MSB is as it is assigned to the output of MSB, that is gray. Here you can see 0. Now the 0 XOR with 0, output is 0, so here you can see output bit is 0. Now 0 XOR 1, output is 1, so here you can see second bit of gray is 1, and 1 XOR 1, that is output, here you can see 0. So for all the 16 combinations you can see the output. Okay, so this is how we have to write the RTL code for the binary to gray code converter. Basically in this video we have discussed the concept of binary to gray code converter. We have discussed 4-bit binary to gray code converter, the truth table, and the RTL design implementation of 4-bit binary to gray code converter. Now I'll stop here. If you are watching this video, then please click on like button, and if you are new to this YouTube channel, then please subscribe to my YouTube. Thank you so much.